Now in this problem, the mass 10 kilograms, the length 0.45 meters. So the y coordinate is 0.45 sine theta. What does it take to maintain equilibrium when theta equals 60? And the mass, 10 kilograms is 98.1 newtons. So here's that idea. The moment, positive moment, works out to be positive d theta and positive delta y. Next slide. So we do a positive virtual displacement. A couple moment, the weight do the work. So the distance things travel in the ye is y times the sine theta plus some constant b. Differentiating this, you get this. And of course, moment delta theta tells you the work of the moment that the moment's doing. So there it is right there. Moment delta theta minus the weight delta y. Delta y is 0.45 cosine theta delta theta. And we get everything in terms of delta theta. Let's consider this problem here. Just spring force, 200 pounds per foot. At 0 degrees, unstretched length of the spring, which you'll notice is 2 feet, which is exactly this plus this. Determine the angle of equilibrium with a 50-pound cylinder. So if it's 0 pounds, this is the unstretched condition, neglecting the mass of the members. So we get the spring stretching. That is going to be the spring constant times how much it stretches. Well, it's twice 1 feet, by the way, 2 feet minus 2 feet cosine theta. So here's 1 foot cosine theta. Here's another foot cosine theta. That's where we get the factor 2. And we get this kind of number here. So the force, spring force, is going to be given by this. Now, we need to figure out the virtual displacements. So the x sub d, that's this little one here, is this 1 foot times the cosine theta. X sub b is going to be 3 times that. X sub d, another x sub d here, another x sub d here. 3 times that. So there we go, right there. 3 foot cosine theta. And then the y is going to be sine. Going to depend on the sine, and it's 2 feet sine theta. Differentiating, well, anyway, you get these numbers. So, moving on, delta U equals 0. That's what the condition we're looking for. Fs delta Xe minus Fs delta Xd, they're in opposite directions, which is why you have the negative sign. Yb, 50 delta Yb, it's going in the same direction. So, Fs, right here, delta Xe, 50 delta Yb, just like in the previous slides. So here's the Fs again. Now, there is a problem. This doesn't belong. a mistake in the slides. It illustrates that even the smartest, most learned professors make mistakes. I want you guys to know that because you'll make mistakes, and don't be too hard on yourself about that. So let's keep going. Let's get the pen off, and I want the laser pointer. Where's the laser pointer? There it is, laser pointer. So now we have this expression. We're going to have some cross terms, cosine theta, sine theta. Here's another cosine theta, sine theta, right here. When you work out the math, you'll see it. Okay. Sine theta times some constant, and then cosine theta, which is right up here. That's this one right here. And set it all equal to 0, and use Solver in Excel or F0 in MATLAB. Either one will work to give you this answer. Next slide. Oh, come on, you silly machine. Move on.